Well, good students. This day we want to look at how to find the eigenvector of a non-symmetric matrix with non-repeated eigenvalue. With non-repeated what eigenvalue. I said we want to look at non-symmetric matrices. Okay, with non-repeated eigenvalues. Okay. Now, what do we mean by symmetric matrix? A matrix is symmetric. Matrix A is symmetric if A equals to what? A transpose. Or if A is not equal to A transpose, you said that given matrix is not what? It's not symmetric. Now, quickly, let's look at one example. And the question is what? Find the eigenvalue and the corresponding eigenvectors of the matrix below. Now, and the matrix is what? A equals to 1, 0, minus 1, 1, 2, 1, and 2, 2, 3. Now, solution. How to find the eigenvalue of this matrix? Remember your formula? Sorry? The formula is what? The formula is what? A determinant of A minus what? Lambda I equals to what? 0. And what is matrix A? 1, 0, minus 1, 1, 2, 1, you have 2, 2, 3. In brackets minus lambda of what? I. What's I? Identity matrix. And since this is 3 by 3, your identity matrix needs to be what? 3 by 3 identity matrix. Okay? And this equals to what? 0. And you simplify this further to give you what? 1 minus lambda, 0 minus 1, 1, 2 minus lambda, 0. You have what? 2, 2, 3 minus lambda. Everything is equal to what? 0. Now, you simplify this. And how do you simplify this? Remember, determinants. You have 1 minus lambda. You cover this, you cover this. Okay, sorry, this is not 0, no. But what? But 1. This is 1. So 1. You cover this, you cover this. And that was 2 minus lambda, 2, 1, 3 minus lambda. This is what? Minus 0, minus 0. You cover this, you are left with what? 1, 2, 1, 3 minus lambda. Minus 1, the last one. You cover this, you have 1, 2 minus lambda, 2, 2. Everything is equal to what? 0. And when you simplify this further, we have 1 minus lambda. Open bracket. This one multiplied by this, we have 6 minus 2 lambda minus 3 lambda plus lambda squared minus this times this is what? 2 minus 0 multiplied by anything is what? 0 minus 1 into this one multiplied by this is what? 2 minus 2 multiplied by the other one, which is what? 2 minus lambda. Everything is equal to what? 0. So from here now, we have it that was 1 minus lambda. When you simplify this, you have it as what? Lambda squared minus 5 lambda plus 4 minus 1 into 2 minus 4 plus 2 lambda. Everything is equal to what? 0. We have 1 minus lambda, lambda squared minus 5 lambda plus 4 minus 1 into minus 2 plus 2 lambda equals to 0. And we have 1 minus lambda, lambda squared minus 5 lambda plus 4 plus 2 minus 2 lambda equals to what? 0. And here we have 1 minus lambda, lambda squared minus 5 lambda plus 4. 2 is common. Here we have what? 1 minus lambda equals to what? Equals to 0. And from this last step, we can what? We can see that 1 minus lambda is common to both sides. Okay? 1 minus lambda is common to both sides. Let me go up this side so that we can solve this side. Now, from this side now, from this side, we see that 1 minus lambda is common to both sides. We have 1 minus lambda is common. What will remain here? We have this one left. We have what? Lambda squared minus 5 lambda plus 4. What about this side? We'll be left with what? Plus 2. Plus 2. Close bracket. Everything equals to 0. And in this one, we have A multiplied by B equals to 0. It's either the first one is equal to 0 or the second one minus 5 lambda plus 6 is equal to what? 0. Meaning that lambda equals to 1, or we factorize this other one, lambda squared minus 3 lambda minus 2 lambda plus what? 6 equals to 0. Lambda, we have lambda minus 3 minus 2, we have lambda minus 3 equals to 0. Meaning that lambda equals to 3 and 2. Therefore, a lambda equals to 1 or 2 or 3. That this is our eigenvalues. Now, if your eigenvalues is this, we can then find for what? You can find your what? Corresponding eigenvectors. Now, to find our eigenvector, to find our eigenvector, you find your eigenvector when lambda is equals to 1, when lambda equals to 2, when lambda equals to 3. Now, let's do the first one when lambda equals to what? 1. And that one is what? Is a minus lambda I multiplied by your x1 equals to what? Equals to 0. Where your x1 here is your what? Eigenvector. And your x1 equals to s subscript 1, y subscript 1, z subscript 1. Okay? Now, we have open bracket. What's your matrix A? Matrix A, the other time when we simplify is you can use your dix. You can use dix. Matrix A minus lambda I. Everything will give us what? 1 minus lambda 0 minus 1, 1, 2 minus lambda 1. We have 2, 2, 3 minus what? Lambda. We have what? X1, X2, S what? 3. Everything is equal to what? 0. Now, let me rub this other side so that we can. Okay, or better still, I wrote the whole thing. Where do you stop? Okay, clean everything. Where do we stop? We stop at a minus lambda I x1 equals to what? Equals to 0. And I said A minus lambda I is same thing as what? 1 minus lambda 0 minus 1, 1, 2, 2 minus lambda 2, 1, 3 minus lambda. We have what? X1, X2, sorry, Y1, and what is Z1 equals to what? 0. Now, we said when lambda equals to what? 1. And when we substitute 1 for lambda here, this becomes 0, 0, minus 1. We have 1, 1, 1. We have 2, 2, 2. Okay? And here you have what? X1, Y1, Z1. Everything is equals to what? Equals to 0. And from here, when we look at this and this, they are the same thing. Okay? You can just pick 1 and 2. Okay? And picking 1 and 2, we have that what? 0x1 plus 0x2 minus, sorry, not x2, y minus z1 equals to what? 0. And the other one is x1 plus x2 plus z z1 1 equals to what? 0. From the first one, we see that z1 equals to what? Equals to 0. And if z1 equals to 0, we can find what? We can find others. As I said, let x1 be what? Be t. And if x1 equals to t, what's going to be y2 from here? Y2 becomes what? Minus z1 minus x1. And we have minus, what's z1? Z1 is 0 minus x1. X1 is what? T. And this one is what? Minus t. Meaning that our eigenvector x1, which is what? X1, y1, z1 equals to, what's that x1? X1 is t. Y1 is what? Minus t. And z1 is what? Is 0. Okay? And from here, you can see that t is common. If t is common, what do we have here? We have 1, we have minus 1, we have what is 0. What you have inside this bracket is your what? Eigenvector. Eigenvector corresponding to ladder 1 is what? 1 minus 1 is 0. Now, we continue. And number 2 now is when lambda equals to what? Equals to 2. You do the same thing, you write this down again. That is 1 minus lambda, 0 minus 1, 1, 2 minus lambda, 1, 2, 2, 3 minus lambda. And this time around now, it's going to be what? X2, Y2, Z2. Everything is equal to what? 0. And when lambda equals to 2, becomes what? Minus 1, 0, minus 1, 1, 0, 1. And here you have 2, 2, 1. Everything is equal to x1, sorry, s2, y2, z2. Everything is equal to what? 0. And at this point now, open the bracket again, you have what? Minus x2 plus 0, y2 minus z2 equals to 0. We have x2 plus 0, y2 plus z2 equals to 0. And the last one, we have 2x1 plus 2xy2 plus z2 equals to what is 0. You see that equation 1 and equation 2, they are the same thing. Okay, you can just pick that any of it as one of the equations, you pick the other one as one of the equation. There are ways to solve this, but one of the best way to do this, you can just write x1 over, sorry, x2 over. You don't write the coefficient of x. Okay? We are solving, we want to solve this and what and this other one. We want to solve this and this. Now, we are looking at coefficients. You don't take the coefficient of this. Look at the coefficient of this. It's like your determinant method. Okay? Okay? Let me first and foremost, what's the coefficient of this? We have what is 0, 2, and what 1, 1 equals to y2 over y2. You don't write coefficient of what y. And we have what 1, 2, and what 1, 1. And the last one z2. You don't write coefficient of z. You have what 1, 2, 0, what 0, 2. Now from here, we have that. So, okay, from here that now we have that x2 over, you can just do the terminal method. This one multiplied by this is what is 0 minus 2 times 1, which is what 2 equals to y2 over. This one times this is what 1 minus this one times this is what 2 equals to z2 over. This one times this is what 2 minus this one times this is what 0, which implies that x2 over minus 2 equals to y2 over minus 1 equals to z2 over what over 2, which implies that our eigenvector x2 equals to what? x2, y2, z2. And that is equals to our x2 is what? Minus 2, y2 is what? Minus 1, and z2 is what? Is 2. That is our that is what? That is our eigenvector corresponding to lambda what? Lambda 2. And the last one, you can do the last one too. The last one now is going to be the last one without waste much of our time. We won't repeat this. The last one, okay, let me just write it. Okay, the last one we have what? 1 minus lambda, 1, 2, we have 0, 2 minus lambda, we have 2, minus 1, 1, 3 minus what's lambda. Multiply by what? S3, Y3, Z to what? 3. Everything is equal to what? 0. Now from here now, when lambda equals to what? 3. 1 minus 3, that was minus 2, 1, 2, 0. 2 minus 3, that is minus 1 and 2, 1, minus 1, 1. 3 minus 0, minus 3 is 0. Now, Y3, Z3, sorry, X3, Y3, Z3. Everything is equal to what? 0. Okay? And from there you have the first equation minus 2s3 plus 0 y3 minus z3 equals to 0. You have x3 minus y3. The last one, z towards 3 equals to 0. And if you are taking the last one, you have 2x3 plus 2y3 plus 0 z3 equals to what? Equals to 0. Okay? And from here, you solve x. And when you look at all these equations, you can just use one or two to solve the problem. And you can use the whole thing. Well, I'm taking one or two. I'm taking this and this to solve the problem. This is equals to 0. Now, how do you solve this? You do the same thing. S3 over. You don't write the quotient of S3. You write the quotient of other ones, which is what? 0, 0 what? 0 and what? 0 minus 1 minus 1, 1 equals to y3. We don't write the question of where was minus 2, 1 and minus 1, 1. And the last one z3 over. Coefficient, you don't write coefficient of z, we have was minus 2, 1, 0, And this one will give us S3 all divided by this one, so this is 0 minus 1 equals to Y3 over this one times this is minus 2 minus we have minus 1 again, this one becomes plus 1 equals to Z3 all divided by this one times this is 2 minus what is 0 minus what is 0. Okay, and this will give us from here, this will give us what? S3 over minus 1, Y3 over minus 1, and Z3 over what over 2, which implies that our eigenvector x3 x3 is equal to what? X3 Y3 Z3, and that is what? Minus 1 minus 1 2. Okay, that is eigenvector. Therefore, our eigenvector for the particular question, that question now is what? Is x1, x1, our eigenvector, these are our eigenvectors are what? The x1, x2, and x3. Okay, that is that about non-symmetric matrix. Also, that is about eigenvector of non-symmetric matrix with non-repeated eigenvalue. I'm going to stop there for today. But before we go, I'll give you what assignments. I make sure you do assignments. You submit to me the next class. Okay. Now the assignment is assignment. Now find the eigenvalue and the corresponding eigenvector to the below matrix. And the below matrix is what? Is B equals to 4, 6, 6, 1, 3, 2, minus 1, minus 4, minus 3. Thank you. We'll see you next class. Bye-bye.